This tutorial is going to show you how to do a binary logistic regression on R. As a recap, a logistic regression is used to predict the dependent variable based on other independent variables. For example, can age and sex predict whether you survive the Titanic sinking? In a logistic regression, the dependent variable must always be binary, so this means it will be coded as something like 1 or 0, or yes or no. But the independent variables can be categorical, for example sex, or continuous, for example age. If there is just one independent variable, then you'd do a simple logistic regression, but if there is more than one, then you would do a multiple logistic regression. We are going to be using R to run the logistic regression. So as a recap of the parts of the interface that we will be using, firstly, this top section, this is where you can write and save your script. And secondly, this bottom section is where your code will run and your output will appear. The first thing that you need to do in R is set your working directory. And this is particularly important if you want to load in your own data to analyse. This is because when you read your data in R, it will look for it in your working directory, so you need to make sure it is set where your data is stored. To see how to set your working directory in R, watch the video on the next slide.
To set your working directory on R, you go up to Session, Set Working Directory, and then choose Directory. Here will open all the folders on your computer. So you need to choose the one where you want to store your R scripts. So for example, I will click Documents and Open. And here you can see that we have set the working directory to my Documents folder on my computer.
Next, it is good practice to install and load any packages you want to use at the beginning of your script. For this tutorial, we are going to use the Titanic and the Dipler packages. To install them, you can use the code install.packages and then in brackets and quotation marks the name of the package you want to install. It's important to remember that once you have installed any packages, you need to load them using the library function before you can use them. You only ever have to install a package once and your R environment will remember it forever. But you need to use this library function every time before you can use the package. Then you'll want to read in your data. For this example, we are going to use the Titanic train dataset, which is available from the Titanic package in R, but you can read in your data using the following code. My data is the variable name of what you want to call your data. Then the arrow assigns your code on the right to the variable name on the left. Then you want to tell R what type of file to read in. And finally, you need to tell R what your data file is called. It's important to note that some data files may require you to download other packages in R. You can view the data by using the view function. You just need to type view and then in brackets what the data is called. In this case, it's Titanic_train. Remember that view has a capital V. So this is what the data looks like. For this example, we are going to use the following independent variables: age and sex. And you can see these variables here. And then we are going to use our dependent variable, which is survived, which you can see here. As you can see, our dependent variable is binary. It's coded as 1 and 0, where 1 means survived and 0 means did not survive. And this is why we are doing a binary logistics regression. To run a binary logistic regression, you can use the GLM function on R. We are going to run a binary logistic regression to predict whether age and sex predict survival on the Titanic using the following code. Firstly, we are going to store our regression as a variable called model. This will help us view results later. Then we add the dependent variable first, which in this case is survived. Next come our two predictor variables, sex and age. Then we need to tell R that we want to do a binary logistic regression. And finally, we need to tell R the dataset we want to use. Remember that as we have stored our regression as a variable called model, to view the results you need to type and run the word model. So here are our logistic regression coefficients. These give you the change in log odds of the outcome for a 1 unit increase in the predictor variable. For example, a 1 unit increase in age, the log odds of surviving is minus 0.005. Indicator variables, such as male or female, have a slightly different interpretation. Here, being a male changes the log odds by minus 2.5. However, viewing results this way does not give us any extra information, such as the p-value. To get further details, such as the p-value, we can use the tidy function from the Broom package. So first, we need to install the Broom package and load it using the library function. We can then type tidy and in brackets model to view the data. So here are our results. And importantly, here are our p-values. As you can see in this model, age is not significant, but gender is. This means that whether you were male or female affected how likely you were to survive the Titanic, regardless of what age you was. We can also use R to produce odds ratios. Odds ratios are used to quantify the relationship between variables. Odds ratios are the probability of an event occurring divided by the probability that it will not occur. For example, if the event had a probability of 0.3 of occurring, it has a probability of 0.7 of not occurring, and this produces an odds ratios of 0.42 or 3 to 7 odds. If an odds ratio equals 1, then this means that there is no difference between the odds of the two groups. If the odds ratio is greater than 1, then this means that there is an increase in odds for that group. And finally, if the odds ratio is less than 1, then this means that there is a decrease in odds for that group. To extract odd ratios on R, we can use the exponential function using the following code. Remember that model is a variable name for our logistic regression. And here are the odds ratios. So the log odds for sex show that being a male decreases your chance of survival, as the odds ratio is less than 1. And the log odds for age show that there is no difference, as the odd ratios are very close to 1. Lastly, we can use the model to predict the chance of survival by certain characteristics. For example, we can use the model to predict whether a 50-year-old male or 50-year-old female's chance of survival by adding a data frame including these characteristics to our model using the following code. And here are our results. As you can see, a 50-year-old male had an 18% chance of surviving, and a 50-year-old female had a 73% chance of surviving. You can have a go and change the characteristics yourself, but remember that age was not a significant predictor, so it's unlikely to change your results that much if you change the age from 50 to 30 or 50 to 80. And now we can see how to run the whole thing on R using the following script.
This tutorial is going to cover how to do a binary logistic regression on R. The first thing that you need to do is install any packages you may need. To do this, you can type install.packages and then in brackets and quotation marks the package name, like these two lines of code here. For this example, we are going to use the Titanic and the Dipler package. I've already got these packages installed, so I do not need to run this line of code. as once you've installed a package, your R environment will remember it forever. Next, you need to load the packages using the library function like this. You just type library and then in brackets and quotation marks your package name. You need to remember to do this every time you want to use them. So as you can see, these two packages are now loaded. We're going to use the Titanic train dataset, which is available in the Titanic package, and you can view it by using the view function. Remember that view has a capital V. As you can see, this provides data about people aboard the Titanic, including their name, their age, their sex, and whether they survived. And we're going to use this dataset to run a binary logistics regression. We are going to see whether sex and age predict whether or not you survived the Titanic. As you can see, survived is going to be our dependent variable, and it is coded as 1, which means survived, and 0, which means did not survive, and this is why we are doing a binary logistics regression. To do a regression, you can use the GLM function. Remember that your dependent variable always comes first. And don't forget to say that we want to do a binary regression by typing family equals binomial. We're going to store the regression as a variable called model, like so, as this will make it easier to see the results later. So let's run our model. And to view the regression coefficients, you can just type in model and run that line of code. And here you can see our regression coefficients. To view the p-values, we can use the tidy function in the broom package. So first, you need to install and load the broom package, like so. And then you can use the code tidy, brackets, and model to view the results. So as you can see, sex was a significant predictor of whether or not a person survived the Titanic, but age was not. We can also use R to extract the odds ratios, and you do this by using the exponential function. So here are our odds ratios. And finally, we can use the predict function to predict how likely a person is to survive. So for example, a 50-year-old male or female. And here are our results. As you can see, 1 refers to males, as this is the first variable that we entered, and 2 refers to females, and both of these are 50 years old. As you can see, a 50-year-old male only had an 18% chance of surviving, compared to a 50-year-old female, which had 73% chance of surviving. And you can change numbers, so for example, the age, and see if it makes a difference. So for example, we could do age equals 30. But again, the results are very similar, because as you need to remember is that age was not a significant predictor of our model. To understand the code in more detail, please refer back to the slides.